Too close to a star and your planet melts. Too far and it freezes solid. Life needs something in the middle. Too far and every ocean freezes. No liquid water, no chemistry, no life. Just a giant frozen rock drifting in the dark. Then there's this. Liquid oceans, breathable air, life everywhere. Earth hit the cosmic jackpot. But why? It's because Earth sits inside a very specific zone around the sun. Scientists call it the Goldilocks Zone. What exactly is it? Why does it exist? And could other planets be inside one? Let's break it down. The Goldilocks Zone is the range of distances from a star where liquid water can exist on a planet's surface. Why liquid water? Because life, as we know it, completely depends on it as a solvent for chemical reactions. Water can exist as ice, liquid, or steam. The habitable zone is where temperatures keep it liquid. That's the key. In our solar system, the habitable zone runs from about 0.95 to 1.37 astronomical units from the sun. Venus is at 0.72 AU, just inside the zone, but its atmosphere caused a runaway greenhouse effect. Too hot. The zone isn't just about distance. A planet's atmosphere changes everything. More greenhouse gas means more heat. The name comes from the fairy tale, Goldilocks and the Three Bears. Not too hot, not too cold. Just right. Here's our solar system. The green ring is the habitable zone. Earth is centered, Venus is inside, Mars is outside. Venus is 0.72 AU away. Its thick carbon dioxide atmosphere created a runaway greenhouse effect. Surface hits 465 Celsius. Mars sits at 1.52 AU. Its atmosphere is just 1% of Earth's pressure. Average surface temperature is minus 60 Celsius. Earth at 1 AU. Average surface temperature is 15 Celsius. Liquid water covers 71% of the surface. Perfect. Mars wasn't always like this. Evidence shows liquid water flowed on its surface about 3 to 4 billion years ago. Mars is small, its core cooled fast. No magnetic field. Solar winds stripped the atmosphere. It fell out of the zone. Earth's magnetic field protects our atmosphere from solar wind. Without it, we'd end up like Mars. Tectonic plates also help. They recycle carbon dioxide back into the mantle, keeping our atmosphere from overheating. Every star has a habitable zone, but its size and location depend on the star. Cooler stars have closer zones. Planets in red dwarf zones are often tidally locked. One side bakes in constant sunlight, the other side freezes. Massive blue stars burn hotter. Their habitable zones are farther out. But these stars don't last long enough for life. Blue stars burn out in millions of years. Life on Earth took billions. They simply don't last long enough. What about two stars? Binary systems exist, and some could have habitable zones, though orbits get complicated. 70% of all stars in the galaxy are red dwarfs, so most habitable zones in the universe are close-in red dwarf zones. Tidally locked planets might still have life. The narrow strip between day and night sides could be temperate. Stars like our Sun, G-type stars, are the best candidates for complex life. Stable, long-lived, only 7% of stars. The Kepler Space Telescope found thousands of exoplanets by watching stars dim as planets crossed in front. Over 5,700 confirmed exoplanets now. Hundreds are in their star's habitable zone. The list grows every year. Kepler 452b, nicknamed Earth's cousin. It's 60% bigger than Earth, orbits a sun-like star, and sits in the habitable zone. Proxima Centauri b is the closest, just 4.2 light-years away. It orbits a red dwarf in the habitable zone. TRAPPIST-1 is incredible. 7 Earth-sized planets around one star. 3 of them sit in the habitable zone. TRAPPIST-1e is the most Earth-like of the 3, rocky, similar size, potentially liquid water on its surface. JWST is now analyzing exoplanet atmospheres, looking for water vapor, oxygen, methane, biosignatures. 3 biosignatures together, oxygen, ozone, and methane, are hard to explain without life. JWST is searching now. There's even a galactic habitable zone. The galaxy's center has too much radiation. The outer edges lack heavy elements. Our sun sits right in the galactic habitable zone, about 26,000 light-years from the center. We got lucky again. But here's the twist. Europa and Enceladus have liquid water, and they're far outside the habitable zone. Expanding the definition, tidal heating. Jupiter's gravity constantly squeezes Europa, generating heat. That keeps its ocean liquid, no sunlight needed. Scientists are rethinking the zone. Subsurface oceans expand the definition far beyond just distance from a star. Rogue planets drift through space with no star. If large enough, could internal heat and subsurface oceans support life? We define the zone for carbon-based life needing water, but other life chemistries might not need these conditions at all. The habitable zone is just the first filter. Being in the zone doesn't guarantee life, it just makes it possible. Current space missions focus on rocky planets in habitable zones. That's where we're pointing our best telescopes. The nearest habitable zone planet we know of is Proxima Centauri b, just 4.2 light-years away. Incredibly close cosmically. Within 100 light-years, there are about 14,000 stars. Every single one has a habitable zone. Somewhere around each. The problem, small rocky planets in habitable zones are the hardest to detect. This small rocky world is barely visible, so tough to confirm. But that big hot Jupiter? Obvious. Next-generation telescopes like the ELT will directly image Earth-sized planets in habitable zones within the decade. If JWST or future telescopes detect biosignatures on a habitable zone planet, that changes everything we know. The implications visualized, we would not be alone. Habitable zones are everywhere. The universe should be full of life. So why haven't we heard anything? That's the paradox. Or maybe Earth is rare. Being in the zone isn't enough. The magnetic field, moon, plates, everything working together. The Goldilocks Zone. The range around a star where liquid water can exist on a planet's surface. That's it. Earth's in the zone, plus a magnetic field, a large moon, tectonic plates, and a stable star. All of it. Hundreds of habitable zone exoplanets confirmed. More found every year. We're just getting started with the search. The zone is a starting point. Europa proves liquid water and maybe life can exist outside it too. The universe is full of habitable zones. Whether any of them have life is the biggest open question in all of science. Next video, what if Jupiter changed its orbit? Spoiler, it would be catastrophic for Earth. Don't miss that one. If you're into this kind of content, subscribe. We drop new space science every week. The bell keeps you notified.